All right, we're looking at the example on page number 8 of your packet, number 20. And here we have a position versus time graph. So x on the vertical axis, time on the horizontal axis. So that automatically tells me that if I want to look for velocity, I need to look at the slope. If I want to look at the acceleration, I got to look for the concavity or the curvature of that graph. All right, so they ask me to find what is the velocity at each one of these points. Okay, so what do I notice about A and B? They're on the same straight line, meaning they have the same slope. So all I need to do is find the slope of this line to find the velocity at A and B. So I go ahead and I'm going to pick these two endpoints, and I get a slope of 6.7 meters per second. You'll note that it ends at 40 meters, starts at 20 meters, so it goes from 40 minus 20 gives me 20 meters of a displacement. So we got 40 minus 20 divided by my time difference, which was 3 seconds. So I went, final was 3 minus initial 0. And so that's where I got my 6.7 meters per second from on that one. The slope at C, it's a flat horizontal line, so the slope is 0. D, E, and F. Now F is just starting to curve right after F, but it's still on that straight part. So all I need to do is go ahead and find the slope of this line. I'm going to pick this point here, the 40 point, and I'm going to pick this point here, the 0 point. So it actually drops 40 meters in just 1 second. And so final was 0 minus the initial, which was 40, divided by the 2 times, which were what, 6 and 5? So final minus initial, so 6 minus 5. Gives me negative 40 meters per second. That negative is important because what is that negative telling us? Direction, yes. So these have a negative 40 meters per second. And then how about down here at G, when the slope switches from a negative value to a positive value? In order to go from negative to positive, you have to go through 0. So the slope at G is 0 meters per second. Okay, and then again, D, E, and F here all kind of go with that negative 40 meters per second. There you go.